There it is. Hi, welcome back. It's always funny how long all this as equipment takes to load. Today is going to be kind of an impromptu, probably a little bit of a shorter than regular stream. There's a couple of things that were on my mind and I really wanted to get them out and address this. Today I want to talk about data serialization, and we're going to touch on rubber duck debugging because I actually had to break this guy out. This one's tough. This is a tough concept. And part of rubber duck debugging is just the act of explaining your problems. And unfortunately, you get to hear about my problems. So, data serialization is an act that we're going to be using primarily to save everything that we need to save as we continue on with this project. There are a lot of components that your player is going to interact with that you need to remember as time goes on. And one of the first problems that you're going to come across when you start doing this is every single time you load your test environment, it's going to start you a brand new game. And it's going to do that every single time until you figure out how to do this. And it seems complicated. And I'll be honest, it kind of is. But as you build your project, the objects that you want to serialize and save will become much more obvious. A lot of the parameters that you really need to pay attention to when it comes to creating a save system is really how you would be doing this. I just spent the better part of an hour trying to come up with a save file format and finding a location that every conceivable device will always have and will be able to read and write from. So whether or not I deploy this on a mobile device, PlayStation 5, make a Steam or an itch page for it, every single game system out there has a user folder. And this should give your game the ability to have read-write access to it. The remainder of the conversation is unfortunately about pretty intermediate programming concepts. Saving and serializing data is realistically recording a bunch of bit flip operators and opening, editing, and saving a physical file on a file system. And none of that has to do with gaming. That, I think, is where a lot of the gaming tutorials really tend to fall short. I know a lot of YouTubers out there are, they're trying to get something off the ground, they're trying to explain things in a way that makes sense to you, they're trying to get you started on a project, but they're not going to walk you through and hold your hand the entire way. And I get that. I do. I really understand. But there's going to be parts that you guys are going to get stuck on. And that is hopefully where I'm hoping to fill in the gaps. There's a few save system tutorials out there that are okay. They're not great. But what there is, in every single conceivable language, are fantastic programs and wonderful tutorials and a lot, so much documentation about file manipulation. So if you know what to look for, you can find these things relatively easy. But I came into a similar problem a couple of days ago when I was trying to design a user interface. I need inventory. Inventory is very important in almost every single game. So you're going to have to come up with a way to both store it, record it from session to session, and display at least visually to your player to be able to select it. That seems like something you would find in a game development tutorial, but the best places to look for that, unfortunately, is within your standard app development community. They'll get into very, very complex and very robust ways to use not just the engines, but any type of software development tools to create like scrollable lists, clickable things, items with touchscreen buttons or selectable buttons, how to navigate a mouse cursor if you're not using an actual mouse, how to shift your cursor location up and down, how to put in custom scroll bars, custom box windows, custom buttons, all the ins and outs of making a solid UI, which is part of game development. But not a lot of people want to waste a lot of time talking about interface development or inventory system development when they're trying to get a channel up and running about game development, because it's not really, you kind of need a different set of skills. And I'm sure we're going to come back to this exact conversation again when we get into things like music, because that's, again, very key to the development of this project, but not really gonna find that in a game development tutorial. There will be within the Godot's engine documentation how to fire off when to play certain tracks, how to add sound effects, how to put in music, but the actual music creation and putting it into a file format that can be used by the engine, that's gonna be hard to find. There will, however, be thousands of music creation tutorials for whatever software we end up picking. So when we get to that part, just like we're doing right now, we're going to be moving outside of the scope of game development and into just raw programming. Which is why game development is considered to be an advanced topic. Not just because of the type of programming that you have to use, which it is kind of frustrating. Once you start working in an actual game loop and see the importance of not putting code within it, you'll see what I'm talking about. So, how do you do all of this if the game development tutorials are severely lacking? Now, one thing that I rely on and have relied on for a great long period of time is my duck. There's an old programming concept called rubber duck debugging. And I don't know if they actually used physical rubber ducks. Maybe that was just something a guy was talking about. You could say it was anything. But because of the old legends, I tend to use an actual duck. And these are cheap, and they squeak. Sorry, my dog doesn't like the squeaking. You okay? I know. So, the concept behind rubber duck debugging, and any of you that have ever had to try to solve complex problems have most likely come across this exact same scenario. You're stuck. Can't get past it. You've tried everything. Everything you can possibly think of. You can keep at it. What you end up finding is that you desperately need help. And whether there is somebody to help you or not, you're going to start talking about the problem. Programmers notoriously are without friends, so that's probably where the duck came from. If you describe your problem to the duck, more often than not, you're going to solve it. Because the act of phrasing it in a way that can be externally understood is going to help you internally understand it in a different light. So, we're going to spend a lot of time talking to this duck. He actually helps. He's a really good programmer. Not really, but it's really just a matter of relating the problem into usable information, explaining that to something that doesn't have access to the information within your brain, and by the time you get through that process, whether you actually have found somebody that can help you or not, you usually sort it. So we worked with the duck. We worked with the duck a lot, trying to figure this one out. And what I came up with was a short list of items that actually need to be serialized. And this short list is not short in the slightest. This is so long. There's so many things. And I'm really not even doing that much. For instance, I'm not saving your location as a player. I don't really care where you are, where you went. I'm not saving the status of any enemy types, whether they've been destroyed and removed from the engine or if they're still actively in play. Every time you reload a save, every time you come back to anything, anytime you die, anytime you start the game, you're going to go back to your previous checkpoint and all the enemies are going to be there. So that's nice. I don't have to store, 35,000 bits of information to record whether or not you've landed an attack on a particular enemy. All I need to know realistically, is the things that you have touched that will stay permanently affected. I need your inventory, I need the items that you've grabbed, doors, levers, elevators that you've activated, checkpoints that you've received, bosses that you've beaten, and the current inventory. Which is why we skipped building the inventory system and went right to saving, because you can't really use an inventory system, even if you make it almost perfectly. When you try to load your game, it's empty because you never saved what was in it. So you have to run around and repopulate your inventory in order to then try it and test it. It's a nightmare. So when you get to this point, you think, well, I now have a player, and I have objects, and I have enemies, and you can run around the world, and you can do all these things, so let's build the inventory. What you actually need to do is build a save system. And thank you for the duck for helping me with this. So, once all of that is done, and you know the list of objects that you need, like I said, my short list got pretty big, then you have to go through and figure out a way that you need to serialize it. And when I say serialize, I'm using that as a generic term to encompass how you will be storing your data to be read later. Originally I thought maybe just a text file. That should work, right? We can just write it all in there and then pull it back in. But a lot of the things that get saved and serialized from a game engine are stored as game objects. And a text file has no idea what a Godot game object is, so when you write it to the file, you'll be writing a game object, but when you read it, you're just going to be reading text. That doesn't really work. So, you can find ways to sort of split the difference. The Godot game engine, in particular, offers a .tres file, or a text resource. And this will store things in an actual game object, which will allow you then to read them back in a game object, because it's a file format that's native to Godot and designed to be used for this particular use case, which is something you find deep in the documentation. Which is nice, because if you want to store a vector 2 for the player location, you can do that in that file, and then you can just read it back in. So, then, once you've figured out what you need to serialize, how you're going to serialize it, what file type you're going to use, and then where you're going to put that file type, which in Godot specific areas is one level above. Let's check. Yes, one level above. So in the basic folder structure resource, you have the entirety of the game, and then as a same level folder, there's one named user. So you'll save it into there. That way you'll have full read-write access on the device level. You'll always have it on in your development environment. Don't let that screw you up. You can put that save file anywhere, so long as you're still working in your dev environment. And it will work, because you have read-write access to all of it. As soon as you port that over to a mobile device, or whatever you have with a dev kit, it's not going to function anymore, and you're not going to be able to save, and that's a really, really, really hard problem to debug. Why is my save file only working on my laptop? It doesn't really cover a lot of the read-write access stuff, but once you know that, you'll probably always know it. So then, mind you, all of this is just to get to start an inventory system. Then you have to go through and make a list of every single thing that will actually need to be written into that file. And then you have to start building out the default file. See how quickly this explodes into a massive project when it was supposed to be a sub-part of the inventory system. So, as you go through the list, you'll find ways that you can logically craft and serialize your individual data. Chest status, for instance. You'll have to record every individual chest, but opened, true or false, is usually enough. If it's opened, then you can just read that back in. When you go to that area, the open status will then be displayed by setting its sprite status to what it is, and your inventory, current inventory should reflect that. Inventory itself is going to have to be handled with a series of arrays, I think, and one really complex dictionary. But we'll cross that bridge when we come to it. For now, just wanted to let you guys know I'm still on track working on the inventory system, but the subtasks for it have expanded so much that they became an entire task all onto itself. So once there's a functional save system, we can get back to the art and we can get back to actually designing the graphical user interface and setting up the inventory, linking the buttons, and trying to see if we can't give Trevor that little helmet finally. Alright, I think that's really all I wanted to cover today. Just as it was going through my head and I was actively talking to this duck, I thought, this is a good tool. You guys need a duck. Trust me on that one. Alright, as always, like, subscribe. If you have any questions, leave it in the comments. I try very hard to get to every comment that gets left. And, I completely forgot what I was going to say. Oh, right. Standard scheduled stream on Thursday, and we'll actually test out the save system. I'm going to spend the next day or so trying to build it.